Look at that. Didn't even count down. Hello and welcome back to Calculus 1, the chain rule. The most important and the most precious of all derivative techniques, and by far the most frequent, most used synonyms, right? We are going to take a look at how to take derivatives of composite functions. So it's very rare for you to take derivative of just sine x or e to the x. It is more frequent to take the derivative of sine 2x or sine x squared or e to the tangent x. We are going to use function composition to combine two functions into a new function and then learn how to take derivative of that. And most of your work later on will be using this derivative. So it is extremely important that you learn this, because a lot of your stuff later on depends on this. We start by first talking about function composition. Which is all the way from pre-calculus 1, where we have f of g of x, also known as fog, right? The little circle is not actually O, but people read it as fog. It is f composed with g. I will write this in blood. This over here means g of x is plugged into f of x. So as an example, if I have f of x to be x squared plus 1 and g of x to be, let's say, e to the x, then f of g of x would be g of x squared plus 1. So hopefully you see that this x is replaced by g of x, and the form of the function f stays unchanged. So we are replacing x with g of x. You did this when you replaced each x with x plus h for your derivatives. Now we are replacing this x with an entire function g of x. So now what would that actually equal to? Well, it would equal to e to the 2x plus 1. Because g of x is e to the x, and when you go e to the x squared, you get e to the 2x. Much more interesting is g of f of x, which is backwards, and that's going to be e to the x squared plus 1. So when I was learning this for the first time, I like to have these funny things going in my head. I say, okay, who's the boss, right? Is it f of x or g of x? One of them has to be the boss, which means the whole problem takes that form. And the other one plugs in. Now, you can chain many of these, and we'll see those as well. But the fundamental idea is, if the f is the boss, then the whole problem looks like something squared plus 1. If g is the boss, the whole problem looks like e to the something. And I hope you can see that. So now, let's see. Let f of x be square root of x plus x squared, and g of x to be sine x. Find f times g, f composed with g, g composed with f. So try this one on your own. I mean, talk to people sitting next to you if you like them. If you talk to them, I mean, you know.
Or the class part?
We'll do at the beginning of the class.
I can't.
We're gonna bring it tomorrow
Okay.
with the rest. All right, so for the multiplication, all we do is we distribute, right? So it's root x sine x plus x squared sine x, and we're done. So that's when you multiply. But then we have composition. And if f is in charge, then the problem must look like square root of something plus something squared. And those x's get replaced by g, so we get sine x instead of those x's. The next one is the g, so we get sine of root x plus x squared. So that's what we have. No, that's it. These are just function composition. Now we're going to learn how to do the chain rule for this. Again, we're not going to have too many proofs and so on, because we have the regular class. So let's go first with the idea of the chain rule. If I have function inside the function, so that should look like I should take the derivatives of all of them, right? So I need, so I'm going to start by first noting that y equals f of x has the derivative dy of dx. So y in respect to x. So if I replace this x with g of x, then it would make sense to say that I'm taking the derivative of y in respect of g. So it would be dy dg, not dy dx. But I need it eventually to be dx. So what's missing over here is this another piece of dg dx. So that's the piece that we call the chain, which actually helps us finish off the problem. So let me one more time go through this argument. I will erase it, but I want to go through this argument one more time. So if I have a function which has another function inside, I take the derivative regular way, so that will be the whole dy, or you can call it df, whatever, but it will be in respect to whatever is in here, and in this case is dg. Now you know that you must end with dy dx, because that's what the slope of the line is, right? That's the rate of change in y over change in x. So I need somehow to go from this dg into dx. So why not just put a dg over dx? These guys technically cancel, and you are left with your dy dx, which is what you need. Now, since this is a repeat, I'm just going to erase it because you have it above. So by this token, if I have multiple chain functions, I can chain 5 of these if I want to. You say f of g of age of x. How would the derivative go? Well, the derivative would say dy over dg, and then we have dg in respect to the age, and then finally I have the age dx. So the most inner function is the one that gets the regular derivative we learned before. And now if you look at this, the g's die, the ages die, and you're left with dy dx. Now, I'm not sure if this is making sense as I'm talking in general terms, but I find that students quickly learn it when there are examples. So say you have function y equals sine squared x, like this. So in my mind, immediately I see the boss function, right? That's the boss. The boss function is x squared, and sine x is plugged inside. This is the skill that you already need to have, because this was pre-calc 1. So when you're looking at sine squared x, what you see is that, well, maybe this form is better. You can write one or the other, they mean the same thing. Once you have this, you see that x squared is the main thing, and then x is replaced with sine x. And you have sine squared x. So now if I want to find the derivative, I will take the derivative of the outer function first, but I have to have sine x plugged in. So the derivative of sine squared x is 2 sine x. And then I am multiplying by the derivative of the inside, which is cosine. That's the chain. The goal of the class is to do 5,000 exercises, so this makes sense. Usually at the beginning it doesn't make sense. Let's take a look at the polynomial. Say you are trying to find the derivative of 4x squared minus x plus 1 raised to the 13th power. Well, you have two choices. One is to actually FOIL this 13 times, good luck. Or learn the chain rule. The chain rule says that you have x to the 13th as a boss, and then you have 4x squared minus x plus 1 plugged in. So what is the derivative? The derivative is 13 minus x squared plus 1 to the 12 times the derivative of the inside, which is 8x minus 1. So maybe this example would give a better picture of what's going on. I consider the entire parenthesis as x. I know how to take the derivative of x to the 13th. It's 13 x to the 12. So for the moment, I kind of drop from my head that this is complicated. I just say, call it x. So the derivative of x to the 13 is the 13x to the 12. Now, when I was learning this the first time, I called this a mess. So I said, what's the derivative? Instead of x, see x and a mess, kind of x mess, right? So I say, what is the derivative of mess to the 13? It is 13 mess to the 12. And then times the derivative of the inside. That's the chain part. So previous example now that contains trig works the same way. What is the derivative of sine x squared? It's the derivative of mess squared, which is 2 times mess, and then times the derivative of the inside, which is the derivative of sine cosine. I used to assign words like that to anything, you know, the boss, the mess, this and that, and it kind of works for at least process side. Let's take the derivative of square root of x squared plus sine x because we can. So what do we get? First, I'm going to rewrite this as the 1/2 exponent, because it is 1/2 exponent. And then I just say, well, what is the derivative of x to 1/2, of mess to 1/2? It is 1/2 of mess to the negative 1/2 times the derivative of the inside. And then to simplify it, or to write it in a concise form, done deal. Oh, fake. Let's take the derivative of e to the x squared plus 9x minus 18. You want faster than that?
What did it do in the denominator?
So which one is the main function? E to the x. So what is the derivative of e to the mass? It is e to the mass times the derivative of the mass. You always take the derivative of the mass. Done deal. Find the derivative of sine x squared. So what's the answer here? What's the boss function? Sine x. So what's the derivative of sine of the mass? It is cosine of the mass times the derivative of the mass. There's a big difference between sine squared x and sine x squared. The first one has sine times sine, the second one has x times x. Have to be very careful where this square is. It's not the same. The same rule goes for ln. Ln squared is ln times ln. Ln x squared is x times x. So you have to be very careful with that notation. And you can also see that their derivatives are different because those are two very different functions to begin with. Now I would like to take one or two from the textbook, and then we're going to take a look at spicier cases. Now in the textbook they have something that say version 1, version 2 of chain rule. Guys, it's just a chain rule, all right? So whatever the hell they talk, you just take the chain rule anyway, you know. It's a derivative. You don't need versions. Wonderful example. Secant e to the x. It's a textbook example. Beautiful. Absolutely beautiful. So which one is the main function? Secant. What's the derivative of secant? Secant x tangent x. So it has to be secant mass tangent mass times the derivative of the mass. So secant mass tangent mass times the derivative, which is another one of these. And to make it pretty, there we go. That was textbook problem number 17, if you're interested in those little things. Ooh, look at this. Nice. What happened?
You're saying it's got to be spicy.
No, it's just beautiful. Secant x plus tangent x to the fifth. It's amazing. Look at that. That's problem 33.
Hey, I got a question. So remember that thing you said you hope we know? Like finding which is like the main function, the boss?
Yeah.
I don't know that. So how do you do that?
Well, you look at the you forgot to the fifth power over here.
So it's x to the fifth, right?
Yes,
The
that's
main
the one. So it the whole thing. So that means that everything would be starting from there. 5 times the mass to the fourth, right?
Yeah.
And then the derivative of the inside is a chain.
Okay.
So where do we start?
The sum rule.
No. What's the boss function? X to the fifth. So we go 5 mass to the fourth times derivative. Actually need the new line. 5 mass to the fourth times the derivative of the mass. So the mass is secant x plus tangent x, and then the derivative would be derivative of secant is secant x tangent x plus derivative of tangent x is secant squared x. And now you can see that you can factor out secant. So the whole thing is 5 secant x times, in parentheses you have tangent x plus secant x, and then you have all of that times secant x plus tangent x to the 5th. At the 4th, yes, sorry. And then what you see? So what does that mean? Yeah, they go again to the 5th. Well, derivative of e to the x is e to the x. It's interesting. Let's take a look at spicier stuff. How many functions are we nesting here? 3. What's the most outer boss function? X cubed, very good. This cube on cosine is telling us that the whole thing is something cubed, mess cubed. Okay, what's the one layer inward? Cosine x. And what's the most inner layer? X squared plus 1. So I don't know if you want to go inside out or from the outside in, whatever. But if you are able to see that this is the base, then cosine on top, and then cube on top of everything, you can do it that way. So now what is the derivative? The derivative says you start with the outer function, which is x cubed in this case, so that means 3 mess to the square. I don't need the parentheses there. Times the derivative of the inside, and that's the cosine. What's the derivative of cosine? Negative sign, and we have to keep its mess. And then times, finally, the chain. So we have 2 chains on this one. And now all you need to do is to simplify this. It is 6x, negative 6x, negative 6x cosine squared of x squared plus 1 times sine of x squared plus 1. Now there are more things you can do, but this is good enough. The derivative of e to the x squared. What's the boss function? E to the x. So hopefully you have this within a few seconds. Let's go. Chain rule is just about working out 5,000 problems to get used to the chain. What's the boss here? E to the x. So what do I write? And then? And then? Cosine x. Nice. That's it. So we have cosine x times e to the square root sine x divided by 2 square root of. You don't have to rationalize in this case because you will not be doing any further calculations.
Hey, Professor, where's that cosine x coming from? The last problem?
So you recognize the form for square root derivative, right?
Yeah.
That's square root derivative from there. So what's the derivative on this one?
0.
0. Nice. Is there any x around? It's not a function. It's a computation. e to the 10 is a number, sine of that number is 0. I mean, sine of that number is some number. When you take derivative of the number, you get 0. There is nothing special there. All right, so those were actually spicier problems. This was the introductory problem into the new section of this section, which is the annoying problems. What other rules do we know? We know product rule, we have quotient rule, and they all work together with the chain rule. You can have a chain rule embedded in a product or a quotient, or you can have a product and quotient embedded into chain, or you can have chain embedded in a product and product embedded in a quotient, and a quotient embedded in a product and chain. Either way. Let's see how that goes. These problems are not difficult, they are annoying. There is a difference between the two. As long as you know the product rule formula and the chain rule formula and the quotient rule formula, it will just be now not just which function is on top, but which rule is the boss. And then within that, what's happening. So let's start with something simpler. So looking at this problem, what do you have? What do you have? What rule do you have? What's the main rule for the whole problem? Product rule. So you have to spot the product rule here because you have multiplication of two functions. So we are going to spot that the product rule is the boss rule for the entire thing. And then as you start doing product rule, chain rule or quotient rule or something else might pop up. So the product rule goes copy the first times derivative of the second, right? Plus copy the second times derivative of the first. Aha, that's what the chain rule is. So now you start thinking, okay, what's the boss? What's this? What's that? So the boss is e to the x, so e to the x squared times 2x is the chain. So this was the chain embedded in the product rule. Oh, I did not factor and do the rest. Hold on, one more. So we have 3x squared e to the x squared plus 2x e to the x squared times x cubed plus 1. What can I factor? I can factor x e to the x squared, leaving me with 3x plus 2x cubed plus 1. And now you can fix the inside there as a polynomial. Is 2x cubed plus 3x plus 2. All right, let's take a look at this problem one more time together. I have my f times g, which triggers product rule. The product rule is f g prime g f prime. So if you look carefully, I have copy f, so copy the first and then derivative of the second, plus copy the second and derivative of the first, which is the chain rule because it's not e to the x, it's e to the x squared. It's a composition of two functions. And then as you go down the the line, the rest is algebra. Oh, remember that formula that I asked you to memorize? What's the boss function? So, and what's the derivative of AX? So there you go. Derivation for the formula I asked you to memorize. I asked you to memorize the same thing for sine, cosine, tangent, and so on. What's the derivative of tangent of AX? What's the derivative of tangent? So secant squared AX times, what's the derivative of AX? Very good. Voila. So let's see what the textbook thinks you should know. Textbook is asking you to take the derivative of tangent of x e to the x. It's problem 60. Let's see.
Yeah.
So I put in a, so I wanted to replace my dog, 25, but I think it's still good.
Okay, when did you start with pencils? I will figure out what we're going to do. Oh no, I removed it because I removed the. Yeah, I removed. I forgot to erase the page. Okay.
Okay.
No, there was no. Yeah, there was no. If the test is on the easier side, I don't have a replacement. There is spicy one. So we'll talk later.
Okay.
Or
I'll probably
if,
just have to.
if you want to go home, you can go.
So
home.
I'll just watch it online. Alright, I can click in now.
So I don't get this. This is bad for me. I have no idea what's going on. So how do you tell? Is the boss function tan x or is it e to the x? How do you know?
Tangent x, because this x e to the x is plugged into tangent. Right?
That might be an issue. Because I was just thinking of it as like tangent times x e to the x, but it's e. It's x e to the x being plugged in as
tangent.
x of tan.
Yes, as x of tangent. X of tangent was replaced by that. So you have the product inside the. Yeah.
Okay, so then you take the derivative of
Mhm.
tan x. What is that? Like secant squared or something?
Yes.
Secant squared x, and then multiply that by x e to the x again, and then see, I'm lost again. Because then what do you multiply the
Well, now you have to do the product over.
product? Well, I don't know, but are you doing the product rule of just of
X to the x.
secant squared x?
No. Secant squared x is on the outside. No,
So
that's
then you
good.
do the-
Don't erase that. That was good. All of that times
And then you do the product rule of these two.
Or the inside, yep. So the main problem here, the main function is tangent. The derivative of tangent is secant, so we have secant squared of x e to the x times the derivative of the inside is a chain, which will be copy the first, derivative of the second, plus copy the second times derivative of the first. That was the product rule, yes. I usually like to put a red dot to signify the product rule there. We can kick out e to the x, so the final thing would be e to the x kicked out. We have x plus 1 times secant squared x e to the x. There we go. So that was the problem. Now let's take a look at one more, 58, and we're done.
No, I took it during the spring. Yeah, that's
Wait, why S is here? Five. Do we have a group of 3 or no? Do you wanna? Yeah, I have a. Yeah, you have 2. So I was thinking, because you have 2 and you guys have 3, maybe combine it into a group of 5. That way. Danica, and Ryan. So that way you have a group of 5. Because everyone else is groups of 4 and 5. Having a group of 2. Because one of their classmates just disappeared. What is the boss rule? Product, quotient, or chain? Chain is the boss. And what's plugged in? Quotient. So we have 8 e to the x over x plus 1 to the 7th. That's how we deal with the derivative of mass to the 8th. Is 8 mass to the 7th. And then times the derivative of the inside is the quotient rule. So take the denominator squared x plus 1 times the derivative of the top minus copy the top and the derivative of the bottom. There we go. So we can factor out e to the x on top. So we have 8 e to the x over x plus 1 to the 7th. And now we have e to the x, and we have x plus 1 minus 1 divided by x plus 1 squared. So these ones drop. And now we have 8e to the x. Oh, there's an x there as well. So let's call 8x e to the x times e to the 7x divided by x plus 1 to the 7th. I am distributing this, well, applying the 7th power. And then over here I have 1 over x plus 1 squared, because now I can combine all of these things. You see I have this e to the x and this one, so that makes e to the 8x divided by x plus 1 to the 9th power, because I have 7 over here and 2 over there. That's altogether 9. So if you want to write this in the nicest possible form, that's 8x e to the 8x divided by x plus 1 to the 9th. That will be the most simplified answer that you can find.
What can 8x yes? Where's that x coming from?
That's this x here.
Okay.
You're welcome. One more note, quick note, and that is that every quotient rule is actually a combination of the product rule and chain rule. So if you are a masters of product rule and chain rule, you can actually forget the quotient rule. The note here is that you are taking the derivative of f divided by g, but you can rewrite that as the derivative of f times g to the minus 1. So this is actually now the product rule with chain rule for g minus 1. If you are interested in mathematics, you can actually try to rewrite a quotient rule as the product, and then, I mean, do the problem both ways and make sure that the answer you get is the same. So all of that is what the chain rule. We will do a few more examples tomorrow to start off the day as a warm-up, and then we'll push for the other sections. So quizzes start tomorrow morning, right, for the exam, which you voted to be next Tuesday. Okay.